minus
what?
minus 10.
10?
And then you divide by -5 on everything. And you should get y equals 1/5 x plus 2.
Beautiful. Flip to the other side.
Okay, and then
Can you write the equation next to it? What was it, 1/5? Y equals 1/5 x plus 2?
Yep. It's 2.
Got it.
All right. So
All right, keep going.
positive 2, so up 2. And then you want to go down 3/5. And then fill the line. And then same position at 2. And you want to go up 1 and over 5. Draw a line. And your point is 0, 2.
Perfect. Awesome. Yep. The answer's right, it's just a coincidence, so you need to fix your slope and then change your slope. All right. So, how's it been so far? Great. Not bad? Awesome. All right, next one. Here we go. It's not going to get a lot worse. In fact, some of these problems will get a little easier. All right. Here we go. Example 4. Y equals 1/2 x plus 2 and y equals 1/2 x minus 1. I'm doing this one with you. What's my y-intercept for the top one?
2.
Okay, up 1 over 2, up 1 over 2, up 1 over 2. And the other equation has a y-intercept of what? -1. And it also goes up 1 over 2, up 1 over 2, etc.
Parallel.
They're parallel. Which means what? No solution. Can somebody tell me why are parallel lines no solution? Lincoln.
Because they will never cross, it is gone.
Right, and the goal of this is to tell ourselves where they cross, right? And if they never cross, and then it's no solution.
How do you get an infinite solution?
Man, if only there was one more example to show us exactly. It's almost like I thought of that question, but I'm glad you said it. So example 5, flip to the back. Can anybody think of how a infinite solution could happen? Yeah? No, perpendicular lines cross. And they cross in one spot. Yeah? Two lines right on top of each other. All right, so imagine this. Imagine if I graph a line, look up, and I'm trying to see where they cross, and then the second line turns out to be exactly the same line. Where do they cross then? Everywhere on the line. That would be an infinite solutions, and we're going to do one example of that really quick. Here we go. All right, I want you to write down 4y minus 6x equals 16, and then next to it on the right, 9x minus 6y equals negative 24. Now, these two lines, just looking at them, don't look like the same thing, but we have to solve for y. I'm doing it with you. Here we go. What should we do on the left side? Add 6x on both sides. Now I'm left with 4y is equal to 6x plus 16. Then what? Divide everything by 4. All right, can you reduce this in your head? 6/4 reduced? Yeah, but 3/2. Everybody getting that? This is 3/2? Okay, because it was 6/4, and if we reduce that, if we divide by 2 on the top and the bottom, we get 3/2 x plus 4, because 16 divided by 4 is 4. All right, so this is one of my lines. I'm going to flip it to the other side and write down y equals 3/2 x plus 4. Back to the back. Now what? Subtract 9x. Moving the x first, we've got negative 6y equals negative 9x minus 24. Divide by a negative 6. Y equals, what's a negative divided by a negative? A positive. Can you reduce 9/6 in your head? Right, 9/6 if you divide by 3 on the top and the bottom. Do you see how it's 3/2 x? And then what's a negative 24 divided by a negative 6? Positive 4. All right, now, do you guys see how these turned out to be the same line?
Indeed.
Okay, so when we graph it on the other side, what should we start with? Plus 4, and then? Up 3 over 2. And grab my ruler, draw on my line. And if I was...
A quick announcement this morning, Mrs. Spencer and Mr. Weese's homeroom should report directly to the choir room today for homeroom, and Vanderplas's homeroom should report directly to Mrs. Kelly's homeroom. Thank you.
We've got a lot of teachers out today.
Spencer's gone.
Yeah.
Are they all sick?
Some have doctor's appointments, and some of them are sick. Some of them had I think Vanderplas is, he went to watch his brother or somebody play, cousin play. Okay, back to this. You're right, nephew. So, I think so, or it's some
It's a relative.
relative. Okay, so here's this line, and we all agree that there are two lines laying right on top of each other. So then instead of writing parallel, you're going to write same line, infinite solutions. On Monday, you will have a day to work on this assignment. The assignment is page 395. Numbers 11 through 16, so just 6 graphs. There will be some that are infinite solutions. There will be some that are no solutions. There will be some that cross at a point. I don't care if you decide that you want to use, I like this big paper because it's blank on the other side and I can do my work on the back side there if I need to solve for y. Your call. Either grab this right now or grab this red paper right now so that you have some ground paper to do this assignment with. And remember, you will have a work day on Monday.
Red? Alright.